Yes. Picture this, a single hyperscale AI data center drawing over 100 megawatts of power. That's the equivalent of 350,000 electric vehicles all charging at the exact same moment. And there are hundreds of these things being built right now, all over the country. Today, we're getting into the real story behind AI data centers, what the economic upside actually looks like, what the environmental costs are adding up to, and what the security stakes mean for all of us. By the end of this episode, you'll have a clear-eyed view of what's being gained, what's being spent, and what choices could actually change the trajectory. I've got someone here who has really dug into this from every angle, so let's get into it. What are we actually talking about when we say AI data center?
So at the most basic level, these are warehouse-sized facilities. We're talking buildings that can occupy more than 1 square kilometer, housing tens of thousands of servers. They're the physical backbone of everything from cloud storage to training the large language models that power tools like ChatGPT.
Right, and the scale of demand for these things has just exploded.
It really has. Tech Republic noted that when ChatGPT launched in late 2022, it hit 100 million users within 2 months. Today, it has over 800 million weekly active users. That kind of adoption curve doesn't just stress software, it stresses physical infrastructure in a massive way.
800 million weekly users. That's a lot of servers.
A lot of servers, a lot of power, a lot of cooling.
And to put the energy picture in context, according to the French Institute of International Relations, the information and communications technology sector as a whole accounts for 9% of global electricity consumption. Data centers specifically sit at 1 to 1.3% of that. And AI workloads right now are less than 0.2%, but that number is climbing fast. So it's still a relatively small slice, but the growth rate is what's alarming.
Exactly. Open Data Science reported that data center electricity use is rising as fast as 12% per year, far outpacing general consumption. And in advanced economies, data centers already account for 2 to 4% of electricity use. The trajectory is the concern, not just the current number.
Okay, so before we get into the costs, let's talk about why communities are actually rolling out the red carpet for these things. Because they are. States are competing hard for this investment.
The money is genuinely staggering. Tech Republic reported that in 2025 alone, data center deals hit a record $61 billion globally, with the majority happening in the United States. And according to S&P Global's economic analysis, data center and related high-tech spending accounted for 80% of the increase in U.S. economic demand in the first half of 2025.
Wait, 80% of the increase in U.S. economic demand? That's not a typo?
That's not a typo. And you can see it play out at the local level too. In 2024, Texas data centers paid an estimated $3.2 billion in taxes to state and local governments. And then there's Loudoun County in Virginia. Officials there expected data center tax revenues to hit $895 million in fiscal year 2025. Their entire operating budget is $940 million.
So one industry is basically funding an entire county's government. That's wild.
It is. And it's not just tax revenue, it's infrastructure investment too. Meta's Hyperion data center in Louisiana started as a $10 billion project and ballooned to $27 billion after teaming up with Blue Owl Capital. Google announced $25 billion in AI infrastructure investment in Pennsylvania. These are transformative numbers for the regions involved.
So the economic case is genuinely compelling. But here's where I want to push back a little, because there's clearly another side to this story.
There absolutely is. And it's not subtle. The same Open Data Science analysis noted that the sector's carbon footprint already exceeds that of commercial air travel. Let that sink in. The data center industry, as a whole, is already a bigger carbon emitter than the entire global aviation industry.
Bigger than all the planes in the sky. That's a comparison I did not expect.
And Cornell University researchers published a study in Nature Sustainability in November 2025 that really quantified what the AI-specific piece of this looks like going forward. They found that by 2030, at the current rate of AI growth, data centers could emit 24 to 44 million metric tons of CO2 annually.
How do you even visualize that number?
The Cornell team put it this way. It's the emissions equivalent of adding 5 to 10 million additional cars to US roadways every single year. And that's just the carbon piece. The water consumption is its own crisis. Cooling these facilities could consume 731 to 1,125 million cubic meters of water per year by 2030, equal to the annual household water use of 6 to 10 million Americans.
So we're talking about the water needs of up to 10 million households just to keep servers cool.
Right. And this isn't abstract. Open data science specifically flagged that cooling systems in large centers are already threatening aquifers in drought-prone areas like Arizona. You're building massive water-intensive infrastructure in places that are already water-stressed.
And I imagine communities near these facilities feel the impact beyond just water.
Definitely. The same analysis noted that data centers convert farmland into industrial zones, increase local noise, and can even generate microclimates. And public opposition is growing. $64 billion worth of data center projects have been delayed or blocked in the US since 2023. That's not a fringe reaction anymore.
$64 billion in blocked projects. So communities are actually pushing back in a meaningful way.
They are, and it's becoming a real structural force. You can't just assume you'll get a permit and build wherever you want. The social license to operate is becoming as important as the financial license.
Okay, so here's the question I think a lot of people would ask. Can't we just power all of these with renewable energy and solve the problem?
This is where it gets really counterintuitive. The Cornell study found that even aggressive shifts to renewables only cut AI-related emissions by about 15% by 2030. 15%, because the demand is growing so fast that cleaner energy alone can't keep up.
So you could green the grid and still end up with more total emissions.
Exactly. The Cornell researchers put it really clearly. Even if each kilowatt hour gets cleaner, total emissions can rise if AI demand grows faster than the grid decarbonizes. The solution isn't just clean energy, it's accelerating clean energy deployment in the same places where AI computing is expanding.
So location actually matters enormously here.
It's maybe the single biggest lever. The Cornell roadmap specifically calls out states like the Midwest, Texas, Montana, Nebraska, and South Dakota as far better locations for sustainable AI infrastructure, low water stress, cleaner power grids. And here's something kind of fascinating. The researchers used AI itself to fill data gaps in the study, the technology auditing its own footprint.
That's a little poetic, honestly.
It really is. And the roadmap shows that if you combine smart sitting with faster grid decarbonization and operation efficiency improvements, you can cut CO2 impacts by 73% and water impacts by 86% compared to worst-case scenarios. The path exists, it just requires deliberate choices.
That's actually more hopeful than I expected. But let's shift to something that I think gets underplayed in this conversation, the security dimension. Because these facilities aren't just environmental infrastructure, they're also massive targets.
This is a huge piece of the picture. Security InfoWatch published an analysis noting that data centers, being essential to the economy, are primary targets for hostile nation-states and criminal organizations. And the threat landscape has fundamentally changed with AI in the mix.
How so? Like, what's different now versus 5 years ago?
The speed and sophistication of attacks. A 2026 AI security report from Practical DevSecOps found that the global average data breach cost has reached $4.88 million, citing IBM's cost of a data breach report. And reported cybercrime losses exceeded $16.6 billion, a 33% increase from 2023's $12.5 billion, according to the FBI's IC3 annual report.
33% increase in a single year. That's not a slow creep, that's acceleration.
And here's the organizational gap that makes it worse. The same Practical DevSecOps report found that 68% of organizations have experienced data leaks linked to AI tool usage, yet only 23% have formal security policies in place. That's a massive mismatch between exposure and preparedness.
2/3 of organizations leaking data through AI tools, and less than a quarter have a policy for it. That's not great.
And the nature of the attacks has shifted too. The Cyber Strategy Institute's 2026 report noted that AI-driven attacks made human-paced detection architectures structurally obsolete. Time to impact collapsed to hours, while detection and response times stayed measured in months. You can't fight a machine-speed attack with human-speed defenses.
So the same AI that's powering these data centers is also powering the attacks against them.
That's exactly the dynamic. And it's not just external threats. Security InfoWatch emphasized that insider threat mitigation, detailed access controls, continuous monitoring, personnel training has become a core operational requirement, not an afterthought. The physical and digital security layers have to work together.
So you've got environmental costs, community costs, and now security costs all stacking up on the con side. Is there a point where the math stops working for these investments?
That's the real tension. And I think the honest answer is it depends entirely on how they're built and where. A Texas A&M and Harvard research paper on electricity demand and grid impacts made the point that understanding AI data center loads and their interactions with the grid is critical for ensuring both reliable power system operation and sustainable AI development. These aren't separate problems.
Right. You can't optimize for economic output and ignore the grid stability piece.
And the training cost numbers from that same research are striking. Training GPT-3 consumed an estimated 1.29 gigawatt hours of electricity. Training GPT-4 jumped to over 50 gigawatt hours, equivalent to nearly 0.1% of New York City's entire annual electricity use.
For a single model, for one model. And there are dozens of frontier models being trained right now.
Dozens, and growing. And scaling these clusters introduces compounding challenges. A Keysight white paper noted that when AI clusters expand to include tens of thousands of GPUs, even minor network delays can result in prolonged job completion times and inefficient resource utilization. The infrastructure has to be engineered with extreme precision.
So it's not just build it and it works. There's enormous ongoing engineering complexity.
Exactly. And a Cisco survey cited by Keysight found that 89% of respondents plan to deploy some form of AI-ready data center clusters by 2026. So this isn't a niche trend, it's becoming the default infrastructure expectation across industries.
Which means the stakes of getting it right or wrong are enormous.
Enormous and immediate. Alan Kaiser, a senior technology advisor at AFL, put it well in their scaling white paper, quote, "Generative AI has emerged and grown at a scale and speed that has surprised us all. It is built on a platform of multiple technologies, all of which have also advanced at scale and speed. This is an extraordinary technology story. And extraordinary technology stories come with extraordinary consequences."
I want to go back to something you said earlier about the e-waste piece, because I think that's one that flies under the radar.
Yeah, it's easy to focus on energy and water, but Open Data Science flagged that rapid hardware turnover in data centers leads to significant e-waste and resource consumption. Recycling remains insufficient, and the environmental toll extends through supply chains for steel, concrete, and semiconductors. The footprint isn't just operational, it's embedded in the manufacturing and disposal cycle too.
So the full life cycle cost is even higher than the operational numbers suggest.
Right. And that's part of why the Cornell researchers emphasized that projecting impacts wasn't enough. You need an actionable roadmap. The study's lead researcher, Professor Fengji Ye, said the question isn't just what environmental trajectory AI will take, but what choices steer it towards sustainability. That framing matters. It's about agency, not inevitability.
Agency, not inevitability. I like that, because I think a lot of people hear these numbers and feel like it's already decided.
And it's not. The roadmap is real. Smart sitting, grid decarbonization, advanced cooling systems, higher server utilization. The Cornell study found that better cooling and efficiency technology alone can cut an additional 7% of CO2 and 29% of water use on top of the gains from sitting and grid improvements. These are stackable solutions.
Stackable solutions. Okay, so let's start pulling this together, because we've covered a lot of ground: economic upside, environmental costs, security risks, the scalability challenge. What's the through line here?
The through line is that AI data centers are genuinely both things at once. They're economic engines and environmental liabilities, and the outcome depends almost entirely on the decisions being made right now about where to build them, how to power them, and how to secure them.
And those decisions are being made at a pace that communities and regulators are struggling to keep up with.
That's the core tension. The $64 billion in blocked projects tells you that communities are starting to assert themselves. But the $61 billion in deals that did close in 2025 tells you the momentum is still overwhelming. It's a race between deployment speed and governance capacity.
And the security piece adds another layer, because even if you build sustainably, if the facility becomes a target and gets compromised, the downstream damage is enormous.
Exactly. And the Practical DevSecOps report made a point that stuck with me. Only 24% of enterprises have a dedicated AI security governance team. You're building the most critical infrastructure of the digital economy, and less than a quarter of organizations have someone specifically responsible for securing the AI layer of it.
That gap between the scale of the investment and the maturity of the governance around it, that's the thing that keeps this from being a simple good news story.
It's not a simple story, but it's also not a hopeless one. The Cornell roadmap, the Texas A&M and Harvard grid research, the scaling work being done by engineers, there's serious, rigorous thinking happening about how to do this better. The question is whether the economic incentives align with the responsible choices fast enough.
So when you step back from all of this, the record investment numbers, the carbon projections, the water consumption, the security breach costs, here's what this really comes down to. AI data centers are the most consequential infrastructure being built right now, and the choices being made about them are not technical choices. They're value choices.
That's exactly right. Where you site a data center is a choice about whose water supply you're willing to stress. How you power it is a choice about what kind of grid you're building toward. How you secure it is a choice about how seriously you take the people whose data lives inside it. None of these are neutral engineering decisions.
And the economic pull is so strong, 80% of U.S. economic demand growth in the first half of 2025, that it's easy to let those value choices get made by default rather than by design.
Which is why the Cornell researchers didn't just publish the projections, they published the roadmap, because the data alone doesn't change behavior. The actionable path forward is what matters. Smart sitting, faster decarbonization, better cooling, stronger governance. The 73% carbon reduction and 86% water reduction aren't fantasies, they're achievable with deliberate choices.
And for anyone listening who works in tech, policy, local government, or just uses AI tools every day, this isn't abstract. The infrastructure of AI has a very real address, a very real power bill, and a very real water tab. And the decisions about all three are being made right now.
The next time you use an AI tool, any AI tool, somewhere a server is drawing power, somewhere water is being used to keep it cool, and somewhere a security team is trying to make sure your data stays yours. That's the real cost of the AI revolution. And knowing it is the first step to demanding it be done right.
We started this episode with the image of 350,000 electric vehicles all charging at once just to power one data center. By 2030, if nothing changes, we could be adding the equivalent of 10 million cars worth of emissions to the atmosphere every year just from AI infrastructure. But the roadmap to cut that by 73% exists. The question is whether we use it. Thanks for being here for this one on Copilot Podcasts. And the next time someone tells you AI is just software, you can tell them it's also a very, very large building that drinks a lot of water.